Okay. Good morning, everyone. Welcome to the second day of the second international conference and training workshop on household and living arrangement projections for informed decision making. This conference is organized by the Center of for Family and Population Research, CIPR, at the National University of Singapore, in cooperation with Population Division of the United Nations, Asian Population Association, the Center for Healthy Aging and Development Study, National School of Development at Peking University, China Population and Development Research Center, as well as the newly established Population Association of Singapore. Today is our training workshop. We're going to firstly offer 2 training sessions for the ProFamy method and the demo race method separately. In the morning session, we're going to focus on the ProFamy method. This method, advanced method for household projection, and we hope you will benefit from these trainings. Actually, the afternoon session, we are going to introduce demo race method, which will be a good complementary software package for ProFamy method. And therefore, we highly recommend you to attend both of it. The training will be done by the ProFamy development team. In this morning session, I would like to firstly invite Dr. Wong Jung Lin. Dr. Wong Jung Lin is the major developer of the ProFamy as well as the demo race software. I believe her teaching will effectively teach us to know how to use the software, know what is function of the software, and help us to better understand how to do household projections. Dr. Wang, please.
Okay, thank you so much for Professor Feng's nice words and the introduction of the ProFamy and the demo race. Today, I'm going to, sorry, let me first share. Yeah, can you see my screen?
Yes, yes. Yeah, how? Yeah, okay, yes.
Okay, very good. Yeah, today, first of all, I'm going to talk about ProFamy method and mainly focus on the counting system. And then lastly, I will give you the demonstration of the software and the application, how to apply ProFamy software. And for the accounting, for the household projections, we know we have 3 major methods. One is classic headship rate. We already know there's a lot of disadvantage. And we have macro models, and it can handle a large state space with many covariates. And our ProFamy model actually is micro models. And for our model, our longtime collaborator, Professor Conland at Duke University, he summarized 5 core ideas about our ProFamy accounting system and method. I think it's really good. So today I'm going to just follow these 5 core ideas. The first core idea, the ProFamy, as I said, is a macro model, and it is a multi-state accounting model. It is not like other household macro model, and we do not calculate the households, and we deal with individuals. Actually, we calculate, we simulate populations, like extended cohort population model. The difference between the population and projection and ProFamy household projection is that we have extended more status, and we group the populations not only by age, sex, and furthermore, in order to we know how the household organized. So we do need the more status, such as marital status of each person and their co-residence and with children and the parents and so on. Therefore, in our model, you can see and the status identified in our model. In addition to the age, sex, there's a population you have to deal with, right? And we have the marital status. They call this variables M. And for the marital status, and we offer 4 models. One is 4 marital status model, then is the other one is 7. The difference between 4 and 7 is whether or not you're considering cohabitation. And then we need their co-residence status. So we say this variable K, and that is co-residence with parents. And we specify this K with 3 values. 1 is with 2 parents. 2 is live with 1 parent only. 3 is not with parents. And then we also need to deal with children. So current co-residence with children is the C. C is the number of children live together. So that can be 0. So if you do not live with children, or H is the highest priority considered. And we do have the variable P, that is a parity. That's for, actually, that's for women, number of children ever born. And for Chinese state, we have it. It's easy to get this variable. But for most countries' census or survey data, they do not have this parity variables. So in this case, ProFamy accept if this variable is not provided. So we simply just assume the number of children live together is same as equal to the number for parity. I think it works because for the parity, why do we need the parity? That's because when we calculate the fertility, we calculate the number of births by parity, so that we need calculate, we need each woman's how many births they already given. But for the woman at the productive age, for the woman, they have the younger children, mostly they live together. So in US application, even though they do not have this parity variable, and we just assume is the same as coreasons with children, and it works very well. And the last variable is you tell the system the projection period. So for the US application, and we start from 2000 and ending like 2050. And yesterday, I already report the validations and the projections for the US application. And this diagram to show you if you choose the 4 merit status and how many transition rates you need to estimate. And for example, you need to estimate from never married to current married. And from the married, people can get divorced. And from divorce, they can get married and widowed and so on. So we can see for the similar 4 merit status, you still need to estimate the marriage, at least 4 merit status transition rates. And if you considering cohabitation, and the model is more complicated, of course, you need to have the more estimations for the transition rates. In addition, for the single from never married to married, for each status, you have to identify whether it's cohabiting or not cohabiting. For example, for never married, we have never married, not cohabiting, and never married, cohabiting. And based on this cohabiting status, you also need to estimate this kind of transition rate from union dissolution and from not cohabiting to cohabiting. And oh, I'm sorry. Yeah. The second co-idea is about our accounting strategy. As I report before, our model is multi-status model. So we have to deal with individual status transitions. Every year for each person, we have the events occurred, like a marriage or divorce or fertility and so on. So with this needed individual status identified, we won't have huge across status transition metrics if we're adopting conventional computation strategy. For example, if 7 merit union status and 3 status co-reason with parents, and with 6 parity and 6 co-reason with children, if distinguishing in the model, as I report for the US application, one has to estimate across status transition probabilities matrix with almost 200,000 elements at each age of each sex for each race. It won't require huge data sets. It is not practical.
王老师, sorry. Sorry, Dr. Wang.
Yeah.
Can you close the, this, because on the right corner we see this. Yeah, thank you.
Yeah.
Please go ahead. Yeah.
Okay. And thus, we adopt an innovative computational strategy, which was originally proposed by Bungus and further justified mathematically and numerically by Professor Zeng. So this figure shows you the strategy, the accounting system in the ProFamy model. So as I said, we calculate the people with a group by groups, actually it's by matrix. And our strategies, we calculate, we deal with the marital union coreasons with parent-children migration and the survival status. And we should assume it's occurred in the middle of age interval. So we can see this, this arrow line. And for deal with birth, the fertility, so in our system, actually, we assume change in parity occur in first half year and the second half year. That's because for some society, the fertility is mainly depends on the marital status, whether you're married or not married. For example, in China, and mostly the birth is occurred from the married woman, so that we need to know how many women already married in the first half year, or they married at second half year. So that's make our calculation for the birth is more accurate. The third core idea is that we need kind of assumptions. Why we need assumptions? So there's a statistical bias. We know in the real world, mostly allows assumptions. And because there's a limited data source force us, we have to make this kind of assumption. For example, we know the mortality also related with the living arrangement for the oldest old, which is the study discovered by Professor Zeng from his oldest old study. However, it is hard to have the reliable mortality by living arrangement. Therefore, we have to make the assumptions in our model. For example, we assume the marital union status transitions depends on age, sex, and race, but independent of other status. And we also assume the fertility only depends on age, race, parity, and marital status, but independent of other status, as well as mortality I already report. And the fourth core idea is about the consistency. As I said, ProFamy is a macro model, it's a multi-status model. Therefore, we need a lot of transitions, not like population projection. So we have the event, only the event come in and the event come out. So it's easy. But for our system, for our model, we have to deal with a lot of events is reversible. Like people, they get married and then they got divorced and get remarried and so on. And that's one thing. The other things, and because so our model is a 2-6 model. Therefore, for each year, for every events occurred for the male and the female, they have to make sure it's equal. For example, we have to make sure the number of marriages occurred for the males equal to the number of marriages equal to female in the one system, right? How to do this? So we use of the harmonic mean to ensure consistency between the 2-6 and between parents and the children in our model. And the final idea is using national model standard schedules and summary parameters at the sub-national level to specify projected demographic rates of the sub-national region in the future years. So we know the model needs the standard schedules and national, and we have to estimate that. And we also know for the household projections is crucial, is also even more important for the subnational level, for the county, for the city. But the reality is that it's hard to estimate the standard schedules at the subnational level, at small city and the county, because we have to face the limited sample size. So for overcome it, so what we do the standard schedules. We know the standard schedules formulate the age pattern of demographic process. And actually for each country, the pattern mostly is the same, no matter they live to where. For example, for the US application. And we estimate the standard schedules at a national level by race. So like other research discovered that the differential between different states regarding demographic levels that's mainly based on the race composition. So it's important. So we have the schedules by race. It's not crucial whether this race is estimated by each state, but if we have the pattern for the white, the pattern for the black, and we can use these national schedules for the marriage, fertility, and mortality, and apply to the subnational level. And it's crucial to have the summary parameters, such as total fertility rate, genital risk of marriage, divorce, for each subnational level for the small county or small city, so that this can drive your household and the population projections. Therefore, the age, race, sex, specific standard schedules at national level can be employed as model standard schedules for projections at the sub-national level. This is similar to the widely practiced application of model life tables, the Brass logistic relation life table model, like the Brass relational campus fertility model, and other parameterized models in population projections and estimations. So as I said, it's crucial is for the summary measures. So a lot of studies already demonstrate that the parameterized models consisting of model standard schedules and a few summary methods offer an efficient and realistic way to project or estimate the demographic age 6 specific race, so that the demographic summary parameters are mostly crucial for determining change the level and age pattern of the age speaks rate, as long as the standard schedules reveal the general age patterns. And lastly, I want to give the conclusions of the ProFamy extensive model. We know this is an extended cohort component model, and it does substantially better than the still widely used classic headship race method in household projections. And it is not only beneficial for our research work, and the ProFamy model and software already widely used for consumer and policy maker analysis. We already have the US applications, and for motor vehicle forecasting and housing forecasting, we have the applications, and for Austria, and also for the vehicle consumptions. And in US, like yesterday, Professor Feng introduced, we have the subnational level, and for the small county, and so on. So I do hope our ProFamy model will offering and help you to do your country, your small areas, and household and population projections, and to beneficially to give the right informed decision making. Thank you very much.
Okay, Dr. Wang, can you quit the screening sharing? Yeah, thank you. Yeah. Hello, everyone. I'm going to pick up from here. In order to the teaching arrangement, I already see some professors raise the issue that we need to show the software. So I would like to say, Dr. Wang firstly gave a general introduction about the rationale of ProFamy method. And then here, we are followed by me. I'm going to give a very brief summary of how ProFamy could be used in the real application settings. After that, Dr. Wang will then showcase a real application of ProFamy in Sri Lanka. And then in this teaching, Dr. Wang will also show the operation of ProFamy software. So, so please be patient. Later in the real illustration, Dr. Wang will show the operation of the software. And before that, please allow me to give you a very brief introduction about the general application of ProFamy into different fields. I would like to summarize the application of ProFamy into four application domains. As long as we have the household projections, the ProFamy outcome could be easily linked to many important social economic outcomes. Here, I would like to show the four domains. The first one is for the durable commodities. I would like to raise the case of automobile consumptions. And this is the application we did about 10 years ago for the General Motors. American automakers actually experienced a continuous downturn from 1990 to 2000. And as you can see, the vehicle consumption is highly related to household features. The larger household may would like to purchase larger sized van, and the smaller household may prefer a small sized car. And that's why household characteristics highly related to the automobile consumption. And that is the reason we take automobile consumption as a very ideal scenario for ProFamy to apply. In order to apply ProFamy to the automobile consumptions, we set the different parameters to link with the ProFamy outcomes. First of all, we distinguished 15 types of household type and sizes, which could be predictable by the ProFamy software. Actually, ProFamy can predict more than 15. Here, we focus on 15 major types, also based on the business concerns. And then in order to better serve the business application, we cut America's market into 4 regions: Northeast, Midwest, South, and West. And also, we would like to differentiate different race and ethnicity groups by the white non-Hispanic, the black non-Hispanic, Hispanic, and the Asian and other non-Hispanic. And they are business meaningful. And then we are also differentiate different vehicle types. And we differentiate the cars, the vans, and the trucks. And also we categorize the household income into different levels, including the high income, middle income 1, middle income 2, and the low income. By setting up all these projected parameters, we first of all run ProFamy to project the household of the United States from 2000 to 2025 by different regions. And as you can see, the ProFamy outcome could be summarized in this table on the left panel by different region and by different year. And as you can see, we also show our projections by different household types and by different household size. And to link these household characteristics to the automobile consumption, we need to rely on the available data to get what kind of association between the household characteristics with the automobile consumptions. We rely on different data sources, including American Community Survey, American Housing Survey, and National Household Travel Survey. And from those surveys, we could get the age differentials of vehicle ownership, the racial differentials of ownership, household type differentials of ownership, household income differentials of ownership rate, and regional differential of vehicle ownership rate. As you could easily see, we could link those ownership rates to the projected outcomes of different type of household and to get how much the automobile demands could be in the future years. In order to do that, in a standard application of ProFamy, we always do the validation first. And here is the validation we did. We try to do the projection from 2000 and to 2009. For the 2009, we have the observed data of the automobile consumption in the United States. And we compare our projected outcome in 2009 in contrast to the observed official statistics released by the official agencies of automobile consumptions. As outcome, you can see our projections have very minor difference. The projection, the forecast errors are actually quite small between the projected outcome and the real number. Then we proceed to do the projections. And this is the projection of the entire America by different region. And as you can see, actually the South and the West will have the largest increase in terms of the total amount of motor vehicles. And then we specified those total vehicles into cars and vans and truck. Therefore, from this picture, you can see the market potential at different regions of the United States in terms of different vehicle types. And also, we go further to specify the consumption by different race and ethnicities, which will be very useful for the business concerns. And in addition to the race and ethnicity, we additionally consider the age group. And that will help the business planners to identify their future consumers. As you can see, in the future of America, the middle-aged consumer of the white non-Hispanic group actually will increase and then decrease. And the big significant change is the rise of the older car owners aged over 65 under the white race category. For the other categories, you can see by among the Hispanics, among the Black, and also among the Asians. There's obviously there's a trend that vehicle consumers are aging very fast in America. So for the future market of automobiles, the business really should pay attention to the needs of older drivers. And then this is the statistics about different household size. As you can see, the smaller household size actually increased very fast, including the household size 2 and household size solo living household. The demands actually increased faster than the larger household. So we summarize our basic findings. We find that more than half of the cumulative increase is due to the increase of car. One will also increase fast, which mainly driven by householders age 25 and 40, and the white non-Hispanic household and Hispanic household, and household more than 5 persons. We also find the middle age will make the largest contribution, and then the older vehicle owners increase rapidly. The Hispanic household will play a significant role in the vehicle consumption increase in the next decade. These are some of the major suggestions based on the application of ProFamy in the automobile consumptions. I then move to another important field. Besides vehicle consumption, housing is another important field, highly related to household. Of course, different household will have very different demands of housing. And this type of housing demands is also highly related to the population aging issue. We did this, actually Professor Smith Stanley did this application in early 2000. And his team actually used ProFamy to study the future housing needs of United States and particularly pay attention to the housing needs of the older people with disability. And basically, they are using data to differentiate, to firstly calculate the disability profile of US population, as well as the household with disabled residents using the data. And then they propose three scenarios. For the medium scenario, they assume that the disability rate within the American household will be constant in 2000 level. And later they set two scenarios. One scenario is the disability rate will increase 5% per decade or falling down by 5% per decade. These are very reasonable and common practice of applications to set up the lower boundary and the higher boundary for the forecasted scenarios in the future. And based on that, Professor Stanley's team used ProFamy's outcome to link with the housing needs, particularly link with the housing needs of the disabled household. These are the outcomes. The DSI-1 and DIS2 are different disability measurement, and I will not go to the details. If you're interested, please read the paper. And then this is the projection based on ProFamy about the household, the housing needs of the household, projection of household, a household with at least one disabled resident from the United States from 2000 and 2050. And Professor Stanley's team further proposed a very useful formula to calculate how many newly built household will have a disabled resident. Based on this formula, they estimated that there is a 60% probability that a single family detached unit built in 2000 will house at least one disabled residents using our first disability measure. Based on this kind of formula, we could actually better understand the future housing need of America in terms of how they could accommodate this increasing disabled people in America. I think this is a wonderful application and could be repeated for many countries if you have the rapid housing, the rapid population aging, and therefore housing become a major issue. Actually, yesterday, the keynote speaker, Professor Emily Grandi, highlighted this issue, and ProFamy actually could play a big role in linking the household and the housing needs of the older adults. And later, Professor Smith Stanley's team actually expand this type of study to the state level of the United States. They focus on Utah, Georgia, Florida, and West Virginia. They are with different type of disability profiles, and they successfully applied the ProFamy model to assist their analysis of the future housing needs, particularly for the disabled older America. If you're interested, please refer to their publication at Journal of Housing Studies. So after automobile and housing, I would like to the applications in America. I would like to show a recent application to Hebei province of China. And we are actually using the 2010 census data and then use ProFamy model to project the population and total number of households by rural and urban from 2010 to 2050. Using this projected outcome by ProFamy, we further apply the home ownership rate and the rental rate by the age of householder, reference householder, and household type and household size and number of rooms derived from 2010 census microdata to project the future housing need of the Hebei province. This is the projected changes of the owned housing unit by age of the reference person in 2015 to 2050 compared to 2010. As you can see, in Hebei province of China, in the next few decades, there's very huge increase of housing demands from the older people aged 65. It is very clear this kind of increase is so prevalent, but many focus on the 1 to 2 room owned housing and 3 to 4 room. And also, there's an increase in the 5 room above, but the increase is less significant. Not only we could project the increase of owned home, we could also link it to the rental housing demands. This is the demands for the rental houses. As you can see clearly that older people's rental demand also increased significantly. And further than that, we differentiate different types of housing. As you can see, very significantly, the one couple and one person housing demands increased significantly for the room with 1 to 2 bedrooms and 2 to 3 bedrooms. And that gives a very strong signal to the housing market of China in the future, like what type of housings are truly needed by the future household of China. Obviously, the small-sized household housings are preferred in the market according to our projection. And you can also see the projections by rural and urban, and definitely due to the rapid urbanization of China, the housing demands increased dramatically in the urban part of China, and by different type of bedrooms. And we further list this table for your information. That is as compared to 2010 housing demands for older adults in 2030 and 2050 will increase about 200% and 300% respectively. However, housing demand for young people aged less than 35 will decrease substantially. And this is a very strong policy intelligence for the local agencies to consider how to manage the local real estate market. And also, in terms of household type, we find a huge increase of demands will happen for the one-person household or the single parent and children household. And the housing demands for 3-generation household will substantially decrease. As you can see, our statistics just show the decrease actually is as high as less than 40% of a reduction. Yeah, in comparison with the increase of one person is about 140% of the increase. So obviously, small household size, small sized housing should be the major force in the future market. And here's a summary of our studies for the Hebei province. So this is another illustration for you to see how ProFamy could be useful if you got the result. And thirdly, I would like to talk about the third dimension, which is the environmental issues. Professor Dalton actually used the result from ProFamy to estimate the future trend of the CO2 emissions in the United States and estimate what kind of factors will drive and affect the CO2 emissions. And they are using the well-known PET model. And in the PET model, a key element is about the household features. And you can see the demand and supply are linked to the household final good producers, and then interact with the intermediate good producers and result from the CO2 because of the emission. Uh, and ProFamy has been a contributing factor for this project by project the future household size. And based on the PT model, the results show population aging will reduce the long-term CO2 emission by almost 40% in the low population scenario. An effect of aging on the CO2 emission could be as large or even larger than the effect of technical changes in some case for the United States. And that's a very good application of ProFamy. We could see the potential of applying the ProFamy method to the environmental related issues such as CO2 emission. Now I move to the very last application recently done by Professor Zheng Yi on the household-based energy consumption in China. As you can see, Professor Zheng already illustrated the fact that the number of households actually increased much faster than population. And that gives us a major lesson. That is, if we want to project the future demands of energy, we really need to pay more attention to the change of household rather than the change of population. In this regard, based on Hebei province, Professor Zheng's team projects three resource and energy consumptions, and then the highest increase actually happened to the water consumption. And based on the water consumption, you can see clearly that as compared to the year 2010, home-based energy consumption in 2050 for the one-person only household increased the most, and followed by the two-person household. Due to the trend of household change, we can see clearly the future driver of energy, water, and fuels will be mainly consist of small-sized households, such as one-person household or the two-person household. And also you could see clearly about the division of rural and urban. And this kind of urban and rural division very policy implicated for the investment decisions for the infrastructures of providing the energy and resources to either the urban area or the rural area of China. And lastly, we could see the future energy consumers will be mainly concentrated in the old age group. You can see the relatively huge increase of household-based energy demands for the elderly. And there's a lot of research we could do on this, and in combination with the housing needs, how to provide a better housing and green economy friendly infrastructure design to save more resources of energy for the older people's housing, I think will be a very important topic for the study of sustainable development. Again, let me summarize my talk. And before Dr. Wang showing you the specific application and software operation of ProFamy, I put 5 major application cases in order for you to understand the broad use of ProFamy in consumptions of a durable commodity, in housing, both in the United States and in China, in environmental and pollution issues, and also in the energy consumption issues. With those great potentials of ProFamy applications, I do look forward to have more people joining us in the near future to push this line of research in order to create a better future for the sustainable development of the world. Thank you very much. Now let me invite Dr. Wang again to continue her introduction on the ProFamy software. Dr. Wang, please. You can play the button. Yeah. Thank you. Yes, we can see, no problem. Please. You are muted. Yeah. Yes. Yes.
Okay. Yeah. Now it's my turn and give you illustration of the ProFamy, and it is a really application first, and then I give you a demo of the software. So I think for your part, the major work is for the data preparation. So I list here the steps for you to use ProFamy. And first of all, you need to define the model, like whether it's full marital and semi-marital and so on. And for the data preparation part, I list here, you need to do the base population. Why we need the base population? Because we need the most data. Because for the population, you need only age 6. Here, you need now just the status of K, the distributions of how many people live with their parents and how many people live with children and so on. And the base population mostly from the macro data. And we also need the data for the 100% population, because our model not only forecast household and also we project population, and we also make the results, the projections consistent between the population and the household, so that we have to ensure at the starting point, your study is highly consistent with your data, your population. So we need 100. And we also need the standard schedules. So as I told before, all the rates you need to prepare, and then summary measures. So this is data preparation. Once you prepare this data, you can just click the wrong button of software, and then you got the result. And the result, because this model can produce not only household and also population, so we categorize the result output by population and household. And under each output, you will have the summary table and the detail table. Okay, here is really application. And the data source I used is Sri Lanka 2012 census 5% macro data with about 1 million. And I used Sri Lanka demography and health survey and to estimate the marriage state transition rate. And I used census 2012 100% tabulations for the population, and also for the institutional population. And I also used statistical yearbooks to get the number of marriage and divorce in order to the marriage and divorce level as a year 2012. And for the model, I defined for this Sri Lanka application, I defined the age 100 and format the model, and the health parity is 3, and there is no rural urban race dimension. And I use net race of international migration. And here I consider 3 generations. And just now people ask me, oh, whether your model can deal with extended family. Yes, we did. So for Sri Lanka, we do generate the number of households of 3 generations. Okay, so let me come on to the first part of base population. And for the base population, first of all, we need process the census microdata. Actually, that's your part. The software could not do it. You can simply use the SPS or Stata or Excel and to derive census data and to have the ProFamy input formatted data file with the extension name, the BPI or other extension as well as is a formatted text file. After you finish this data preparation, you get the BPI file ready. So you can click the run button, run base pop, and then you can get the matrix category specified by age, sex, marriage status, and corresponding with parents or children. And then all the data is in this BPO file. And also you get some kind of report table. Okay, here I give you very detailed information. And this is the census data. And you need this personal record, and in the personal record, you can have the variable sex, variable age, and marriage, and so on. And then you just transfer this census microdata format to the base pop model input data file. Okay, just a few variables we need. The variable list here, we need first variable is the relationship with the householder, whether is a household wife or children, and so on. We need each person, age, sex, marital status, number parity, and this household type, whether it's a private household or residential. And with total, we only need these 6 variables. Actually, it's quite simple. Everybody can do it. Just from use Excel file, you can transfer the census microdata to this base pop model input data file. Okay, let me look at what kind of output you will have after you're running base pop. And you will have the number of households by household type and size by direct calculation and the model estimate. And the direct calculation is we just count, or model estimation is we group the people with status, age, sex, marital status, and corresponding parents and children. And based on each status, and we calculate the number of households by type and size. So that is model estimate. And then you will have this population by different arrangement, marital status, and the report tables. And finally, that's you really need the matrix. So after running, you will get the table of the households and the population from your microdata, and also the matrix. Here is the list of all the tables you will get: household by type, size, and the elderly living arrangement, and so on. And here is the result from Sri Lanka. And we can see that this is direct account, this is a model account, and there's a difference with the number, and the percent difference it is really good. And so this table shows us, I would highly recommend you first to look at this table. When you get this result, this means your data, your microdata is good. And you transfer the data from microdata to the format data is good, no error. So you see, for the one male and for the model count is exactly the same as we direct count. So people say, okay, how do you calculate 1 male? So it's simple. For us, for model to calculate 1 male is very simple. For the person who is a male and who do not live with parents, who do not live with children, who live in the private household, and who do not have any relative or non-relative. And then this person is 1 male. So that's our accounting strategy for the household. So we try to find the reference persons by each person's status and to have different households. So that means how many households with 2 generations, that means we have how many different persons of 2 generation households. And here is another example for one of the output. And this is a proportion of living with parents and in Sri Lanka at 2012. The reason I show you this table, because this table is very useful. Because for children living home, you may not get data from the survey to estimate the children living home rate. However, you can use 2 census data. You just give us, for example, if you have the 2000, the census, the proportion of living with parents from 2000 census data, and you also have this proportion at 2010, you just input this data to our software, and then we can estimate the children living home rate by gender and single age. Also, if you can specify it by rural, urban, or race. And so here, you might want to know what kind of data in this we call the extended BPO file. It's actually, this is actually the data for the base population data for the projections. And so first of all, I want to like to tell you, this is a summary data. Accurate data is not individual, because for some country, they have very, very strict rule or policy for using the micro data, so that you can tell them that we only want to use your micro data once, and we just calculate the data with like kind of tabulations. And then you get the data, you do not need to run the macro data again. So it's important to have this BPO file. So in this data, we need, the definition of the model. So that means this define this base population is for 4 marital states or 7 marital states, and what is the age range, and so on. And so we also need some information about relative or non-relative. So people just ask me question, oh, can you multi-deal with relative and non-relative? Yes, we do. So how we deal with? And so we need this kind of information. We need to know how many people, what is the distributions of the relative or non-relative, so that the information is in this data file. And we also need this collective household information for the collective household information. Some countries say this is institutional population. Because for the institutional population, they can, for their status, exactly the same as 1 person only in households. So that we have to deal with this. So how to do it? So for our strategy, we first of all, we deal with this as a population level. So we can now, based on macro data, we can now the proportion of institutional population by age and sex. And also based on the multiple metrics, and we can know the proportion and the age for those who do not live with parents and children, so that we can identify finally who live with institution, live in the institution, who is a one-person only household. And here we can show you what is a base pop the BPO file look like. This part is the really a format of base pop. And the first column is the value, is number of population. This is age. This is status, co-resident with children. This is marital status, and there's co-resident with parents, and there's gender and rural or urban. And this, I give you the list of the real number here. And now we go into the 100% population. And in Sri Lanka, for the model, I defined 100. But in the reality, in the publication, and we only can have the highest age 95. So that I can use the macrodata distribution and to decompose the 95 plus to the single age from 95 to 100. And for the standard schedules part, and for probability of surviving, I use aggregate life tables for Sri Lanka from 2011 to 2013. And I get the, and then I also, because for life table, normally they only have the 5 age group because for the small country. And then I decomposed from 5 age to the single age. And so I'm gonna emphasize that for the ProFamy model, every race we need a single age because we do the cohort by cohort, age by age, so we need a single age. Therefore, for the probability of surviving, I did this decomposed from 5 age group to single age. And I use DHS data to estimate the first marriage rates and the fertility, and also for the net rates of migration. Okay, and because we do the projection, we do need how the fertility change or how mortality change and how metastasis change in the future. So we only have, if we only have some standard schedules, we cannot say in the future is constant. So the method, the software give you the opportunity so you can define your future, how the mortality fertility changes in your study. And this is about migration. So you can give the general rates of migration in or out and net rates. And now we go into the output part. So after you click a run button, first of all, you can look at the summary table of population. So we give the summary of dependent ratio of children, dependent ratio of old, and the total number of population, you know, by older people and younger people and so on. And the further summary table of populations is here. And so in total, this is tables of households produced by ProFamy. So for the households, we not only give you the total number of old ages, we know population is aging and households is aging too. So right now we calculate the household by aged less than 65 and higher than 65. And here is an example of the output of Sri Lanka application. So this is one generation households. We have one person only one person and other, married couple, subtotal, this is subtotal generation, one generation. And for two generations, the summary table give you how many married couple with children, how many household is single mother, and how many households is single father. And here we have this extended family, how many three generation households in the future. And here is percentage. So we can see that in Sri Lanka, the one person only households is increase. And in general, the one generation household is increase as well. And we look at, you see the three generations in the future, the Sri Lanka will decline dramatically from 18, almost 19% will be 6.5% in 2060s. And here we can see the households with the different person with higher than 65. So this elderly household. So we can see in the future, the one person only households will increase a lot. And here is about detail. Just before I show you the summary table population, summary table of household, we also offer you very detailed information of population. Like here, we have the population by age structure and by marital status. And here is how the table look like. And this furthermore, we also give you the list population for each year. This is really application. The Sri Lanka, the population for each year, and this course birth rate will decline, and this course death rate and the growth rate also decline. And this is detailed tables of household produced by ProFamy. I give you this example for the one person only household. So for the one person household, you can know this is for the female and by age and by married status, never married. You can know how many never married households, you know, and for younger age, there are a lot, but when they're getting older and they get married, and we have a lot of female widowed one person only household. Also, there's a lot household, they are married, they are women, they are married, but separated. So that I would like to mention here, and even though Sri Lanka is a full marriage status, but we do considering separation, we just use the proportional method and to deal with separate person because we don't have the transition rate between separate and married. And the one generation household, you will have the table like one person only and one by married status and gender and one person and other. Here you can find out a relative or no relative. That is the households, they have relative and no relative. And couple household and so on. And this also the detailed information of for the number of households and relative and non-relative. So people say, okay, how can we know the relative and non-relative? So you can have the information here. The list, we list here the people who are not single person household, but they live in the residential household as a relative and non-relative, and by age and gender. And this is, we also give you the institutional population by single age and gender and sex. So this information here, I think is important for, this information is important for a lot of countries. For example, in China, it's hard to find the institutional population by age groups because for the census publication, they only give the number, the total number by age. Not by age, only by gender and rural urban. Therefore, we use our ProFamy model method. We based on micro data and 100% data, and then we can calculate the institutional population by 5 age groups. So this information is very important, very valuable for the policymaker, and for the future planning of the institutional fertility for the elderly. Okay, we are going to give you the output part of figures. So by running ProFamy, you can get these parameters. This is Sri Lanka. This is at the beginning parameters. This is at 2060 Sri Lanka population, and by merit status. So we can see the Sri Lanka population are getting aged as well. And this is the output of a household, the average household size. So we can see the average household size, Sri Lanka from year 2012 will come from 3.7 and decrease to 2.8. So Sri Lankan household size will become small and small. And the software also give you the percent distribution of household by types. So you can, by just running, you get these figures, and the table below that's also come from ProFamy and not calculated by myself. So here clearly we see 1% only is increase, and the married couple for the ventilation is increase as well. And this is the figures of household by household size, and the figure and the table and both produced by ProFamy. And lastly, I would like to give you this demonstration and to see how important we should do the household projections. Here is a relative increase of number of household and population as compared with year 2012. And we can, the blue bar is households number, the increase, the relative increase of household. And the yellow bar is the population. So we can see that as compared with 2012 at the beginning of projection, Sri Lanka, the number of households will increase by 80%, but the household only 33%. So that if you only use the population projections result, it might be misleading for you. Energy consumptions planning and housing planning, and also the elderly arrangement, the institutional facilities, and so on. Okay, now I'm going to the demo of ProFamy software. So I first will stop the share, and I'm going to another share.
Dr. Wang, this time you may need to share the screen. Yeah.
Yes, I'm trying. Not this one, right? I'm sorry.
Yeah.
Okay, let me share.
Did you start the software?
Yes, I did. So I
Yeah.
tried to find out.
Yeah.
There's because my computer is very old, so I need a new one.
Yeah.
And I couldn't find it.
Yeah.
Let me see.
There's supposed to be multiple screens. Yeah.
Yeah. Okay. This one. And then I go to share. Okay, maybe I have to. Okay, finally we got this, right?
Yeah, we can see. We can
Yeah.
see.
Okay. This is the screen you will get after you opening ProFamy software. And so as I told, the first step, you should specify your model and the data type. And for the reality, you also need to tell the software where your data located and where you want to put your data. So that is input parts and output parts. That's we say this directory. And then that is, as I told, the model definition. And this is the really application. That's the application I showed you before. That's the really data for Sri Lanka. They start at 2012 and ending year at 2060, and the health age is 100, and we do not consider rural urban, and there's a region dimension and no-risk dimension, and for the marital status, we choose 4 marital status, and for the marital and divorce level, and this is number I got from statistics book. So I want, this is in the census year, number of marriage, number of divorce. And this is, you tell the software what kind of type of the data of 100% population. And then you can define living home, race, and here we already have Sri Lanka children living home race. But once you don't have it, you can click here. You say, okay, I want to use estimate. And then you just give 2 adjusted years proportion of living parents, and the software will help you to estimate children living home. And lastly, you just give the definition of the output, and what kind of what's the way of you have the output. You want every single year, or every 5 years, or every 10 years, or you can specify the years by yourself. And then you give the basic name of output. And this, because we have so many tables, so we just ask you these 4 characters, and then you and us can distinguish which simulations. Normally, we need to do another simulations, so that you just give one name, and then you can know is different simulation. And this is for the base pop, for data preparation part. And here I gave you, this is Sri Lanka, the base the data from macro data, and then you give the location you want to have the output. And if you click the wrong button, and the base pop model just deal with this BPI data, which is formatted, I talked about it before, with 6 variables. And then you can click a run button here, and we can see, and then they will run households by households, and then give you, I showed you before, you see this direct count, model count, and this number difference and the percentile difference. It's quite quick and simple, and by type and percentage by type and so on. So this is base population part. Let me talk about standard schedules. So this is all the standard schedules we need. So this is the probability assignment I told before. I got from the left table, and I decomposed from 5 years age left table to single years. And because population is aging, we also need the ending age groups, the mortality rate. And this is the transition rates we need is the 4 set of marital transitions for the females and the males. And we also fertility frequencies for all parity compared. And we also do need the occurrence exposure rate fertility by parity, and leaving children home rate and migration. And the last part, the other part is the summary measures. So you give you the mortality rates in the future, life expectancy, and the marriage rate, and in the future, and the divorce rates. There's the general rates of marriage, general rates of divorce. Actually, we can see here, there's a green part we call the reference person. So you might don't know directly, oh, what is general marriage rate and general divorce rate in Sri Lanka in 2012. Okay, this is no problem, because you give us the standard schedules of marriage transition rate, how the marriage will happen based on your marriage transition rate and the divorce. And you also give us the total number of divorce and marriages. And here we use multiple left table method. And then we, based on your data, we calculate this general marriage rate and general divorce rate for your reference. Here's the reference. So for me, I think it's very useful, because for me, I just directly use it. And you also just click the button, and they can, automatically paste this reference value to the beginning year. And we do need you give us the fertility rates by parity, so that you do need to calculate the fertility rate frequencies, so that you know the fertility rates for the first birth, and the second birth, and the third birth. And also we need the fertility rates for the all person combined, and then the mean age of birth. So that means you should tell us, based on your standard schedule, in the future, the woman, whether it's delayed their birth or is the same as your standard schedules. So these summary measures will control the pattern of your fertility rates. And the total fertility rates will control the level of the fertility. Same thing at the marriage. So we need the mean age of first marriage. So we can know, whether the marriage happened delayed or early, and so on. And we also need to know the living home level. So we use the proportion of for the age, for the people at age 45 to 49 and not living with parents. We use this measurement to see your living home level. For the Sri Lanka case, and we know this is a proportion not living parents, and we just assume in the future maybe more people living home after they get married, after they got a new job, after for their education, and so on. And this is the age also for your to control the pattern of living home. And this summary measures is for institutional population. So this is the beginning proportion of people living in the institutional population. And for this scenario, we just simply keep constant. And actually, based on Chinese study, we found Chinese population living in institution is increased dramatically. So in that case, we do not, we have to use, we cannot give the constant proportion. We have to, based on the study, the time seriously, to based on historic data to have the right direction of the institutional population. And this is for female and for male. And we also need the proportion of people of elderly living with children. And this is summary measures. You can control how many non-relative and relatives live in the residential household. So you just give us average numbers of other relatives and non-relatives by household size. And if you increase this, this means more people will, as a relative or non-relative, live in the family. And this is sex ratio at birth. So you should tell us your sex ratio. So because based on your data, we know each year how many births, and we will use this ratio now how many males or females newborn. And lastly, you should give us summary measures about migration. And then this is population data. And I strongly recommend you to use this, the population data by marital status. Of course, you can define, said, okay, I don't have it. I only have by age and sex, it's okay. But for Sri Lanka case, actually, I easily can get some population data by age and sex. But I do the further work because I use different sources of data and by different age groups and the macro data, and then I can get 100% population by marital status and age. So in this way, I can make sure that at the beginning of the projection and the population I use by marital status is 100% correct, is accurate, is exactly same with observations. And you also need to give us the total numbers, institution populations, and number of household by size. This can be optional. Okay, after you finish all of this part, so you can say, I want to compute. So I say, yes, I want to run. Okay, so I finished the computation and they say projection computation is complete. So, and then I have all the tables. Oh, sorry. Okay, I need to run again. Okay, do I still share the screen?
No, we cannot see the screen. Yeah.
Okay, so I go share again. Okay. Okay. No, this one's not, right?
No, not this one. Yeah.
Okay. And so I need to share. Do I still share screen?
No, we did not see. Yeah.
Okay, so okay. So now it's share. Can you see the screen?
Yeah.
Okay, sorry. So after we running and here the output part, and we can see the output. You can have the summary of the household, summary of living arrangement, summary of population, and detailed tables and figures, and the population figures and percentage, and the living arrangement figures, and the family and the pyramids. And then you can also have the tables of the detailed household, like one person owning, one couple owning, and so on. Okay, this is the demo of the software. So I would like to tell you that this is our PC version of software. Actually, we developed a long time ago. And about that, 5 years ago, we also developed a web version. And the function and the computation model are exactly the same. So you also can use that web version. And right now, our team also start to develop the software by R. And so in the future, we will have the PHP, probabilities of household projection. So in that package, there'll be in R. Okay, I finished my demo, and any questions and concern and suggestions are mostly welcome. Thank you very much.
Thank you. Thank you, Dr. Wang. And this is a good timing because I think there's some questions, from our panelists and our audience. Our panelists, please feel free to ask questions if you want. Any questions, you can open your video and then ask Dr. Wang directly. Dr. Wang, can you just cancel the screen sharing so we can see people? Yeah. Okay, please feel free to ask, and let me also read. Yeah, I think we have some questions. Let me see. Yeah, the first question is actually from Adam. I think Adam tried to ask for the BPI input file. Some of the variables are not important. Shall we leave it or just put 0 there? Yeah.
Oh yeah. If you like you don't have you don't need the rural, urban, or race, you just leave the 0 or blank. It doesn't matter.
Yeah, it doesn't matter. Okay. Yeah.
We just don't count it. Yeah.
Yeah. And another question is actually is Avi asked that in the raw data, for example, the census data, there might be some data quality issue. For example, there's a digital preference. The age will clustered at 10, 20, 30. So for this kind of issue, what will be your suggestion? Yeah.
Okay, as I said, in reality, for example, for Sri Lanka applications, we also face this. But for our model, we do need a single age. So we have to use some kind of calculation statistical method and to decompose, the 10 years old age group or 5 years to the single age.
I see. Okay, but this part, as I know, that is not part of ProFamy. We need to clean it and fix it before we put into the data, right, Dr. Wang? Yeah.
Yeah.
Okay. The next question, I think Adam also wants to know more about the summary measures. So it is usually the from the literature, established literature, we set it. But how about the summary measures for the future? So usually, what will be your suggestion to set the summary parameters for the future? Yeah.
Okay. So based on our experience, the summary measures is really crucial for your projections. And for example, so if the divorce rate going up and marriage rate going down, your household size will becoming smaller and the number of households will become large. And so how to give the future summary measures? When for us, I would like to recommend you, first of all, you should have one like a medium assumption. That's like kind of educational forecast. You can use your historical data to see how the marriage rate change in the future. You can assume based on the historical data and the future, the marriage rate, whether it's increase or decrease, or divorce rates or increase or decrease, like that. And so first of all, it's better you have a medium assumptions. And then you can use a model to play. Like yesterday, we talk about Sri Lanka application, when we try to locate the number of disabilities people in the future. So we did 3 scenarios, like a large family, a 3 family, small family, and also with a disability rates, so that you can know the range. So the summary measures only help you understand how your summary measures affect in the future's population and households. As my supervisor, Professor Jim Sovapa said, he said, okay, every model is wrong, but every model is useful. What does that mean? He means model is wrong because no model can give you exactly right number in the year 2030. We look at the United Nations population projections. Every year he has to correct, he has to change, right? No one can give you the right number. But why we do it? Because it's useful. We want to know. We want to know how the future would be. So our model, our software, just offer you this opportunity so that you can see how the fertility change and mortality change will affect elderly living arrangement and the population and the households. Thank you.
Thank you. I see, Dr. Wang, I see Adam raise hand. Adam, could you please ask the question by yourself? Yeah.
Yes, thank you very much for the clarifications. I think the demonstration is really great. I have a follow-up questions about the summary measures. So in the demonstrations, I see you put in for some measures you put in 2012, which is the base year, and also 2060, which is I think the last year of the projection, right? So what do the models do? So for example, when we are projecting 2030, so do the software interpolate the 2 measures between 2012 and 2060 to project the output for 2030, or do we need only 2 years, 2012 and the end year, or it is or you recommend us to put more measures in between? So this is the follow-up question on that. Thank you.
Okay, I think it's a very good question. That also I forgot to mention when I give a demo about summary measures. So in the software, and we can give you opportunity. You can, so for Sri Lanka application, I just choose the option of specify the year of the summary measures. And you also can choose, okay, I want to give every year, or I want to give every 5 years, or every 10 years. So the strategy is that we do not need to give you the summary measures for every year or for specific year, but we do need to give you the year at beginning and ending. These 2 years I have to give. You have to give. In the between, the software will calculate for you. The summary in the between. Thank you.
Thank you, Adam. I also see a question and a comment from Professor Iris Ananta. That is migration, especially internal migration, is very important for countries like Indonesia, China, and India. So how do we get this schedule and estimate based on your experience? Yeah.
So you talk about the
internal migration. Yeah.
Oh, okay. The migration. Yeah. Very good question. And for Sri Lanka, we got from the census data, because Sri Lanka, if we do the projection for national, you only deal with international migration. So for the standard schedules, and normally the census question will ask you your last residence 5 years before or last year before. so that you can know this the net migration, the rates. So you can calculate the rates based on the census data.
Thank you, Dr. Wang. I have two questions I actually just posed. Professor Handari asked, are there any limitations of this model in terms of application? Can you briefly talk about the limitation of ProFamy in application? Yeah.
Oh, yeah. So for the limitation at this moment, yeah, right now our model is like a decision making. So you have to tell us, well, you know, the fertility rates and like Dr. Madam just mentioned, oh, how could we give some measures? So all of some measures have to based on your work. You have to tell us how it change. So in the future, we will develop the probability forecasting, and we will have the use models and historical data, and to help you and to know the future change.
Okay, thank you, Dr. Wang. I think the last question, which is also a good question from Andrea, and quite relevant to the session in the afternoon. Andrea said it looks like the transition rates are difficult to estimate. So she tried to ask us, how shall we do it? Yeah, can you make comments? Yeah.
Yes, yeah, exactly. So that is what we're talking about this afternoon. So we have to put a huge part of work to estimate this kind of transition rates. And, you know, first of all, you need the survey data, you have to clean and so on. You need this kind of scale. We need OE rates and the frequencies and so on. That's really tremendous work. If without the demo rates, like Franz Wilkins said, oh, there's could be one person job for a year, you know. And even though you put a lot of effort, you might not estimate correctly. You know, recently, Dr. Samuel from Canadian Statistics Bureau and contact us. He said, oh, the OE rate he estimate might not good. Yeah, he said he might need this demo rates. So I'm happy to tell you that right now we have the software package, and will help user to easily to estimate this transition rates. And also, like Professor Franz Wilkins said, right now it's really a good opportunity for us. And because we don't need the longitudinal data to estimate the transition rate, just the period that is enough. Like a census data, for example, in China, in the census, asked people when they got the first marriage, okay, and whether or not they give birth. So we just use 1 year data, we can estimate the first marriage rate and the fertility rate. So okay. Yeah, I think it's very easy. You know, this afternoon we will report, we'll tell you how to use the demo rates.
Thank you, Dr. Wang. We're almost at time, and I would like to say thank you, Dr. Wang, very much. And this session actually firstly start from a general introduction about the general idea of ProFamy, and then followed by an introduction of its multiple applications. And then Dr. Wang gave us a good illustration about the software and then the different steps based on a specific case on Sri Lanka. I have to say, like this online training workshop is not the ideal format. When we designed this conference, we do hope like every one of you could come to Singapore so that we could, you know, provide hand-in-hand experience for you to even bring your own data to run ProFamy. We are sorry for that. And we look forward in the future, we could have some further opportunities to provide trainings on ProFamy. And then we do welcome that you to ask us if you have questions or having data and want to do household projection in the future. As Dr. Wang said, ProFamy has three basic elements: the baseline population and the summary parameters and the schedule. And it looks like the schedule part is the very challenging for you to estimate. And therefore, the ProFamy team has developed the software called the demo race. In the afternoon session, we are going to use 2 hours to teach you how to use the demo race. And you are very welcome to join us. And we will see you in 1:30 p.m. Thank you.